Good afternoon, everybody. I'm presenting today the presentation on elevated RC tank construction, which was presented before and was in the CSCE 2015, Canadian Society of Civil Engineers 2015 in Regina, Saskatchewan, Canada. This paper was co-authored by myself and two groups actually of my students in the CENG 4253 or 424 course. Uh, these both groups of students were working on the same project on but at 2 different years on elevated RC tanks. So first we need to know the main components of an elevated RC tank. First is the foundation. It could be shallow, it could be deep. Then the supporting system, which could be an RC shaft support or RC frame support or RC braced frame or a masonry pedestal. And the storage tank, which could be either conical shape or rectangular shape. But this is from a structural point of view. However, from a construction method point of view, the supporting system or the concrete shaft is either constructed using what we call the slip form or the jump form, while the storage tank or the vessel itself, it's either constructed using the force work method, which is either the massive structured force work or the conventional method or the suspended force work or the force work lift method, or using the lift slab method. So the first thing that we'll be talking about is the climbing or jump forms. So this type of forms is suitable for construction of multi-story vertical concrete elements in high-rise structures such as shear walls, core walls, lift shafts, stair shafts, or water tower shafts. We have three types of jump formwork. First is the normal or the basic type, which is simply in which the forms are dismantled using a crane to move it to the next level of construction. However, the second is the guided climbing jump form, in which the units remain anchored to the structure but are lifted with a crane to the next level of construction. However, the most automated is the self-climbing jump form, in which no crane is used and it's pushed on rails by hydraulic jacks. So the construction sequence. First, the formwork and the working platforms are assembled on the ground. Then the formwork is then lifted by crane and fixed to anchors and the climbing brackets, which are bolted to the wall below. Then steel is fixed, concrete is poured, and the formwork is dismantled after setting up of the concrete and raised by crane to the next level. However, for a self-climbing form, this is done using a hydraulic jack. On the other hand, slip forms are similar to jump forms. However, the process is continuous, and this major advantage comes from the presence of hydraulic jacks that are pushing the formwork upwards at a constant rate while the concrete is being poured inside the formwork itself. As you can see in this shape, there is an upper platform in which storage and distribution area exists, and a middle platform in which the working area at the top of the poured concrete level exists, and the last or the lowest is the lower platform in which the concrete is being finished. So if we are comparing them to each other, the larger is the scale of the project, the more an automated system like self forms or self-climbing forms will be efficient in terms of cost effectiveness. However, for smaller projects, conventional formworks are of course much more cost saving. The least safe is the conventional formwork. However, the jump forms and slip forms, due to the advancements within the technology itself, they are the safest. However, one of the major disadvantages of the slip forms is that it's non-adjustable. It's a system that once it starts, it should go on while moving at a constant rate or a semi-constant rate, and it could not stop while moving. For a conventional formwork and normal jump forms and guided jump forms, they always need a crane. However, the self-climbing and slip forms, they only need it during the concrete assembly. The site congestion, it's a major disadvantage of the conventional formwork. However, the least congested is the other side, the slip forms. Labors, of course, slip forms need highly skilled labors. The more you could see that the more sophisticated is the method, or the more advanced is the method, the more it will be more capital intensive, and the more it will be needing highly skilled labor. However, it will be also fastest. So the fastest is the slip form, and the slowest is the conventional formwork. But on the other hand, the end product, the durability of the formwork itself, the slip forms is much more durable than conventional formwork, together with the jump forms. And the concrete at the end of the day is very important to maintain, for a slip form, to maintain the rate of pouring that should be equal to the rate of setting. And however, for a conventional formwork, it's a typical thing. Then let's move here to the tank vessel construction. We said that the first method of tank vessel construction is the massive structured force work, or actually this is the conventional method. So you simply, first stage is that you will construct the shaft, then you will assemble the force work and the formwork, and then you will place your reinforcement and or pretension tendons to pour concrete. However, one advancement that could be done is the suspended forcework system. So the suspended forcework system, it has the common factor here that again the shaft is constructed first. However, the second stage is that you will suspend a forcework structure from the shaft and assemble the forcework. So here you don't have that amount of massive forcework to work with like the first one. Then you will place the reinforcement and pour your concrete. The third one is the forcework lift method. So here you assemble the forcework on the ground, and you construct the vessel on the ground, and then you will raise it gradually by jacks during the shaft construction. And this is a little bit challenging, and this is why this method is not that common. And after that, you'll construct the transition, the ring beam, and rest the vessel. Last method is the lift slab method, in which you will first, it's very similar to the forcework lift method. This is why, or the pushed method, this is why some people get mixed up. The only difference between this method and the forcework lift method is that you need to construct the shaft first. And then after that, you start your cycle. You construct assemble the forcework on the ground, construct the vessel on the ground, and suspend the tendons from the shaft and pull them, and then lift the vessel and then construct the transition. But you need to put in mind here is that this method, this ring beam or this transition is very important to be very well designed from a structural perspective, because this connection between this vessel and this shaft is very critical in such a case. So the conventional, of course, the conventional is the most cost saving, and the lift slab is and the forcework lift method, they are mainly for medium to large heights. The risk is high in terms of high probability of worker fall off. However, this is for the conventional and the suspended forcework. However, for the other two, the issue is very critical in terms of lifting and of course in terms of connecting the shaft to the vessel itself. The accessibility limitation is it's not limited in terms of conventional massive force work. However, it is limited in terms of suspended force work method, but it's not limited for the other two. The first two, the equipment is typically simple. However, special equipment are required for the last two. And also the last two require a higher level of skill for the labor. However, they are the fastest for sure. And again, special design considerations should be taken when it comes to the connection between the shaft and the vessel, the beam connecting the two. And of course, however, you have a very high level of quality control exercised when you are constructing the vessel on the ground rather than constructing it up. So we'll discuss two case studies here. The first case study is the 2 million gallon tank in Frankfort, Kentucky, USA, which had a total height of 40 meters and a tank diameter of 35 meters, which is actually one of the first 4 all concrete elevated tanks in the USA, because over there they are used more to steel. So if we discuss the tank geometry, we first have the foundation, then the concrete shaft, the transition, and the tank vessel. So then of course we have the ring beam at the top and the dome. So the construction sequence started by the raft foundation, then the concrete shaft using the jump forms, then the transition section, then the tank vessel formwork. And so here we could see that they had inner vertical members, compression members, and they had outer vertical members and tension members. So it was not an easy task to have this tank vessel formwork. And then, so this is the tank vessel formwork here. Of course, after that they poured the concrete and they constructed the ring beam and the dome. The second case study, it's another elevated RC tank. This height was 59.1 meters. The bowl diameter was 30.5 meters. However, the shape was, it's a semi, part of it is semi-sphere and part is a cylinder. And it's located on the Disney Road. So the sequence started again by constructing the foundation, then constructing the first 3.9 meters using conventional forms, then constructing the remaining height, the remaining 33 meters by the shaft by slip form of the shaft by slip forms, then constructing the wall, iron columns and staircases, then constructing the vessel on the ground, lifting the tank using the lift slab method, and constructing the transition ring beam and releasing the lifting tendons, then constructing the tank roof slab. If we want to discuss these case studies, we could say simply that using slip forms to construct the shaft of the second project, while normal jump forms were used in the first project, as the second tank was higher than the first tank. So it made sense. On the other hand, the higher height of the second tank is the major reason giving the preference to the lift slab method to construct the tank vessel, as having the tank force works constructed at the top of the shaft would be time consuming and cost consuming, while the situation was different for the first tank. The verticality of the walls of the second tank vessel made the construction using the suspended formwork much more difficult than constructing it on the ground, than lifting it using the lift slab technique, while the walls of the first tank were slanted, easing the use of the suspended forcework. So this is basically why these two cases have been applying different methods. And this will tell us something very common here, that a lot of issues within the design and within the site conditions will dictate your decision on which construction method to use. So when examining the methods applied in the two cases discussed here, we could see that the developed design criteria applies to the construction method, and it is highly recommended to use this selection criteria matrix, actually the two matrices developed in this study, in order to decide further on which method to use in which case. I'd like to acknowledge the support of our department, and these are the references.